Today we're going to review some of the basics of trigonometry that we need to go through, that you need to know. So first of all, we need to talk about how to find missing angles and sides on a right triangle. We'll start out with some rules. Okay, so here's tons of formulas. Some of you may already know these, and that's why I just write down you can skip forward. But I'm going to talk through some of them here. So first of all, sine of theta equals opposite over hypotenuse. So what this is going off of is SOHCAHTOA. So if you remember, there's what's called SOHCAHTOA. Okay, now you might have remembered that word and think, I don't even know what that means. Okay, well, SOHCAHTOA, the SO represents that sine equals opposite over hypotenuse, SOH. Ka means that cosine equals adjacent over hypotenuse, and TOA is that tangent equals opposite over adjacent. We'll go over those. We're going to do some examples showing you where those sides are. Okay, now cosecant is inverse of the sine function. So if this is 1 over sine, then that means that this would be the inverse as well. This would be h over O, which would be hypotenuse over opposite. Okay, and then likewise with secant is the inverse of cosecant, and cotangent is the inverse of tangent. Now, I'm not going to spend a ton of time explaining these, but if you need more help on them, please come to me. Something that I always get from students too, you have to know that the tangent equals sine over cosine. Okay, so everything on, and then this is the Pythagorean theorem, a squared plus b squared equals c squared, and then this is just the most awesome formula you'll ever know. That's a Pythagorean identity, because this will simplify problems like you would never believe in later math and harder math. So these are all things that you should have memorized, as well as the unit circle in the first quadrant, and we'll talk about that in a second as well. Okay, so this is all things that you definitely want to write down, and if you don't know them, you'll want to make flashcards of them. Okay, so let's go through an example. Okay, so talking about where each of the sides are in relationship to the angle that you're looking at. So some people ask, like, they want to know where is the opposite and adjacent. Well, to do that, you have to know where your right angle is. So wherever your right angle is, your hypotenuse is always directly across from it. Okay, so this is always your hypotenuse is directly, like if you make the little square in the right angle corner, this would be your hypotenuse. So hypotenuse, I don't even know if that's right. I always say hypotenuse and look like I'm missing another letter there. Anyway, so this is the hypotenuse. This is H. So then, how do we know which side is the opposite and which side is the adjacent? It depends on which angle you are talking about. So you have to look, okay, I'm talking about this angle because that's the angle we're trying to find. So in relationship to this angle, I have two choices. I've got this side and this side. This side touches my angle, but it's the hypotenuse. This side also touches and forms my angle, and so that would be considered my adjacent side. Okay, so that would be A. The opposite side is always the side that is across from your angle that does not touch your angle. Okay, so that would be opposite. So if I want to know what this is, I have values for, on this one, all three sides. So I can choose to use sine, cosine, or tangent. It doesn't matter. So I'm going to use sine just because it's easy to just choose the first one. So the sine of my angle that I'm looking for is going to equal opposite over hypotenuse. So it'll be 77 over 85. Okay, now we need to solve for the angle. This equation, once you write the equation, I need to solve this, so I need to take the inverse sine of both sides so that I can get theta by itself. Because what happens is if I take the inverse sine of sine, it's going to make it so that the sine is eliminated and that you're left with just theta. Because here, inverse sine of sine is itself. So it undoes it and gets it back to theta. So now we need to take the inverse sine of the ratio that we're given. So when you type in your calculator, make sure you push second sine to get the inverse sine of 77 over 85. This will give you approximately, it's like 64.94238. In this problem, you'll notice that the answers are given as whole numbers, so we'll just round it to 65 degrees. Okay, and now the other important thing is making sure that your calculator is in degrees. If you're wanting to find a degree angle, your calculator needs to be in the degree mode. Okay, so what happens if we aren't given all three sides? We're only given two sides. So there's two ways, there's multiple ways you can do it, but one of the things to remember is that you can find other parts of the problem if you want them. So for instance, if you want to know what the hypotenuse is, then you can do Pythagorean theorem and you can find that third side. Or we can just use, with relationship to this, we can look and recognize what each side is. So this side is straight across from an angle, so this is the hypotenuse. This side touches, the hypotenuse always touches your angle. It's going to touch your angle, and the other side that touches your angle is the adjacent, and the side across is your opposite. So here we have the opposite and the adjacent side given to us. So if we use tangent, because tangent uses opposite and adjacent, then we don't even have to use that, find that third side. We can find this angle based off of this. So we'd say opposite is 17 over 35. Okay, so we're going to take this and we're going to find what theta is. The same way, we're going to find the inverse tangent of 17 over 35. And this gives us 25.9, a whole decimal, so I'm going to write it down as a 30-degree angle. Okay, now you can watch, the way that you know if you should round to the decimal or round to the whole degree is just based off of what your answer sheet says. Okay, so those are the basics. Those are problems that hopefully you remember doing. Now finding the sides is slightly different. And really quickly, I should probably mention that 25.9 doesn't round to 30 degrees. Hopefully you guys caught that mistake for me too. This should round to 26 degrees. Okay, so here, now we have a little different setup where we are given an angle, and we're asked to find the missing side. So when you do this, the same thing, we're going to go through and we're going to label things. So here, based off of this angle, the side across from the right angle is always the hypotenuse. The other side that touches it would be your adjacent side, and the side across from your angle would be your opposite side. So looking at this, we want to find the hypotenuse, and we have the adjacent side, and we have the angle. So we are going to use what uses adjacent and hypotenuse, which is cosine. So the cosine of theta equals adjacent over hypotenuse. Okay, so then we're going to go through and fill in the spaces that we know. So the cosine of 53 degrees equals the adjacent side, which is 13.1, divided by x. So now we have a problem that only has one variable, so we're able to solve for it. So using your algebra, and this is one, I'm glad we have this one here. Sorry about the screaming in the background. Just one second. Okay, so this is not always the case that x will be in the denominator. If it is, you need to get it up into the numerator. So what we're going to do is multiply both sides by x. So we would get x cosine of 53 degrees equals 13.1. Okay, now when you have this, now we can find what this will, we can keep going and get x by itself now and divide both sides by cosine of 53. So x will equal 13.1 over the cosine of 53 degrees. Okay, and then you get your calculator out. So now we're not doing the inverse anymore because we have a value to find of the cosine. So using your calculator, you do 13.1 divided by cosine of 53, and you're going to make sure that you are in degree mode, which will give you 21.767, and it goes on. So we're going to round it to the nearest tenth because that's what the answer sheet does, 21.8 degrees. Okay, so those are finding just the basics of those. Okay, let's move on to the next. So these next problems are going to use the same idea. We need to find the cosine and the cosecant in exact values. Now we're not finding what theta is. We are just finding what cosine of theta is. So it's not the angle that we're finding, it's the whole trig value. Okay, so for instance here, the cosine of theta means that we want to find what is adjacent over hypotenuse. Now, if we were asking for theta, we would need to find the inverse cosine of adjacent over hypotenuse, but we're just finding this ratio. So we need to look at the problem, and we need to see we need to label everything. So in reference to this angle, first of all, I guess we look for the right angle first, and this side is our hypotenuse. Okay, now we need to know the other side that touches this is our adjacent, and the side straight across from it is our opposite. So looking at this, we have the opposite side is 3, and the hypotenuse side is 5. We need the adjacent side. So this is where the Pythagorean theorem comes into play. So we need to take a squared plus b squared equals c squared and find the missing value. Now we know that c has to be your hypotenuse. Okay, so this has to be the 5 squared value. But in the a and b, it can be either one. So this doesn't have to be a or b, it can be a or b, it doesn't matter. So we are going to have one of them be a value I'm going to call x, and one of them be 3. And then we're going to solve for x, and that's going to be our value for this side. Okay, so let's go through and do that. So we're going to take, and we're going to solve for it. So we're going to take x squared. 3 squared is 9. So I'm going to subtract 9 from both sides of the problem, and this is 25. So I'll have 25 minus 9, and I'm kind of making a mess here, which equals 16. Okay, so right here I subtracted 9 because this is, so I actually subtracted, I'm going to write it as 3 squared just to kind of show you. But 5 squared minus 3 squared is 16. And then we are going to take the square root of both sides to find the x equals 4. Okay, so that means that this side is 4. So now we have all the sides. So we're going to take and we're going to say, okay, I want to find what cosine of theta equals. Well, cosine of theta equals the adjacent side, which is 4, divided by the hypotenuse, which is 5. Now, if this could reduce, we would reduce it, but you keep it as a fraction, and that is the solution. Okay, now what is cosecant? So cosecant is the inverse of sine, so it will be the hypotenuse over opposite. And because we already have the values, we can say, okay, the cosecant of theta then is equal to the hypotenuse, which is 5, over the opposite side, which is 3. We look to see if it can reduce. Remember, do not change them to mixed numbers. Leave them as improper fractions, but see if they can reduce, and that would be your answer for that one. Okay? Now, it goes one step farther when you are asked to find, and some of these will have, like when you find your value here, just to give you a heads up, and I'll help you in class, some of these will have radicals in them. Because we're looking for exact values, don't write a decimal down, make sure you write a radical. So for instance, if you have square root of 13, make sure you write square root of 13 and you just leave it like that for your ratios. Okay, just do 2 more things. Okay, so the next example, we are going to do one that has, that you're finding exact values using the unit circle. So we did talk about this a little bit in class, and it seems like most of you do have some understanding of the unit circle. So this is the first quadrant of the unit circle. You can find the values of any of the other quadrants based off of the distance from the x-axis. So let's start out with a problem that has, it's in that first quadrant. So if it asks you for the exact value of 39 degrees, okay, well the exact value of 39 degrees, we know that the sine of theta is the y coordinate, okay, which is something else I should write here. If you have your x and y coordinate, this is your cosine of theta, and this is your sine of theta. So if we want to know what the sine of theta is at 390 degrees, well, 390 as we go around means that this reference angle, how far it is from the x-axis, is 30 degrees. So we're going to take the value at 30 degrees and we're going to look at the y-coordinate. So this would be 1/2. Okay. So these ones you're just using the unit circle to find those. So let's take one now. Let's take an angle. Oops, let's do this. Let's take an angle over here. I'm going to say, what is the, if I do, let's see, this is 90, let's do 120 degrees. Okay, so this is a 120 degree angle. What is the cosine of 120 degrees. Okay, well, 120 degrees, what's really important is how far it is from the x-axis. Okay, so this distance right here is 60 degrees, which means that the values that go with this coordinate point are going to be the same as the 60-degree values, the 1/2 and square root 3 over 2, but we're in the second quadrant. So in this quadrant, the x-coordinate is negative, and the y-coordinate is positive. So it'll be negative 1/2 and square root 3 over 2. So what is the cosine of 120 degrees? It'll be the x value, because cosine is the x value. And so this will be negative 1/2. Okay, and you'll get some practice doing that. So hopefully you'll get used to it. And if you don't know it, if that's brand new to you, then definitely ask me some more questions and we can go into more detail. Okay, the last thing that you'll be doing is taking a problem and you will be solving the problem using trig. So for example, if you have 2/5 sine of theta equals 1/5. So the first thing that we need to do is isolate the sine. Okay, so we're going to, whatever the trig function is here, you need to isolate it. So I'm going to take the 2/5 and I'm going to divide both sides by 2/5. Okay, which is the same thing as multiplying by 5/2. See, if I multiply this by 5/2, then these two cancel each other out and that equals 1. So I'm going to multiply this by 5/2 as well. So this becomes 1 and we have the sine of theta equals, we're going to multiply straight across. I can see that 5's can cancel, so it equals 1/2. So then we say, okay, on the unit circle, 1/2 is sine equals 1/2 when the y-coordinate is 1/2. Sorry, all of these examples came out with 1/2. That was not intentional. So here, sine is equal to 1/2 at 30 degrees. So we know that at 30 degrees, the sine equals 1/2. And so theta would equal 30 degrees, but we also need to find if there's anywhere else. Now, when does the y value equal, is still positive and still 30 degrees from the x-axis? So you have all these possibilities, right? All of these ones that are 30 degrees from the x-axis. Well, these two, the y values are negative in the third and fourth quadrant. So the only other option would be here in the second quadrant. It's going to be square root of 3 over 2 is negative, because x is negative, and a positive 1/2. So the sine is positive 1/2 in this quadrant, and this distance here is 150 degrees. And so that would also be a place where this would equal, where that would be correct. So let me make sure real quick here. Yeah, so your answers would be 30 degrees and 150 degrees. Okay, we'll see you in class. We'll do lots more trig.